You're building an agent to analyze a code base, write documentation, run tests, and submit a pull request. That's 4 distinct work streams, each requiring specialized tools, each generating thousands of tokens of output. A single agent trying to hold all of it runs into a context window ceiling. At 180,000 tokens, accuracy degrades. At 200,000, critical earlier context is truncated. The task fails not because the model is wrong, but because the harness can't hold the full problem. This is the inflection point where multi-agent orchestration becomes necessary. Not optional, necessary. The question isn't whether to use multiple agents, it's which pattern to use. Think of a hospital emergency department. One triage nurse, the orchestrator, assesses every patient and routes them to the right specialist. Specialists work independently in parallel where possible. Results converge back at the attending physician for a final decision. That's the orchestrator subagent pattern. There are 4 others: sequential pipelines, where each agent's output feeds the next; parallel execution, where independent subtasks run simultaneously; single agent, which often outperforms multi-agent on sequential reasoning tasks; and handoff routing, where one active agent transfers control to a specialist. Each has a topology. Each has failure modes. Each works best for a specific task shape. The orchestrator subagent pattern is hub and spoke. The central orchestrator receives the task, breaks it into subtasks, and delegates each to a specialized subagent. Each subagent has a scoped context, only the tools and information relevant to its job. The subagent focuses. The orchestrator synthesizes. In incident response benchmarks, multi-agent orchestration achieved a 100% actionable recommendation rate. Single agent achieved 7%. The orchestrator is the most important agent in the system and usually the worst designed. It needs to be reliable at task decomposition and deterministic in its routing. Give it a specific job description, not a general-purpose system prompt. Sequential pipelines are elegant in diagrams and dangerous in production. Agent A's output becomes Agent B's input. If Agent A hallucinates a fact, Agents B, C, and D all build on that lie confidently. A 5-agent sequential chain where each step is 95% accurate delivers only a 77% end-to-end success rate. Parallel multi-agent is different. Independent subtasks run simultaneously, then merge. A centralized multi-agent system outperforms single agent by 88% on complex benchmarks. But the synthesis step is where the complexity hides. 2 agents producing conflicting answers create a merging problem as hard as the original task. Never chain more than 3 sequential agents without a human checkpoint. Handoff routing is the cleanest pattern, one active agent at a time, transferring control when it reaches the boundary of its domain. A billing question goes to the billing agent. A technical question goes to the technical agent. Each specialist starts with focused context. No synthesis required, but the benchmarks show multi-agent doesn't always win. On Gaia, tasks requiring sequential reasoning across many steps, single agent consistently outperforms multi-agent. Every handoff loses information. Every agent boundary is a potential failure point. The right answer is to match the orchestration pattern to the task topology, not to your preference for architectural complexity. Orchestration failures fall into 3 categories. Misrouting. The orchestrator sends the task to the wrong specialist. Everything downstream runs confidently in the wrong direction. Information loss. What agent anew was serialized into text at the handoff boundary. Nuance, context, and implicit assumptions are lost. Synthesis failure. Parallel agents return conflicting results, and the merge step has no principled way to resolve them. The decision framework. Use single agent when the task is sequential. Use orchestrator subagent when subtasks need specialized tools. Use parallel when subtasks are truly independent. Use sequential pipelines for document transformation only with checkpoints. When in doubt, start simpler. Every time you decide on multi-agent orchestration, ask 3 questions. Can the task be decomposed into parallel independent subtasks? Does each subtask require specialized context that would overwhelm a single context window? Can you clearly define the data format at each interface between agents? If any answer is no, single agent is safer. The hospital emergency department metaphor holds. The triage nurse routes, specialists focus. The attending synthesizes, but every additional specialist is another handoff where information can be lost. Communication overhead scales quadratically in a mesh, linearly in hub and spoke. Match the topology to the task. Log every handoff. Pause here.